Hi everyone, in this video we'll know what's the meaning of the intermediate value theorem in simply way, and we have a very simple and direct question about that. So as you see this graph, here we have an interval from A to B, and as you see in this graph that f of A is greater than 0, which is positive, and f of B is negative, it's less than 0 because it is in the negative y-axis. So f of B in this graph is negative, and this is a conclusion of the intermediate value theorem. And this conclusion says that if f is continuous on the closed interval from A to B, and f of A and f of B have opposite signs, then there exists C belongs to the open interval AB such that f of C equal to 0. So when you want to apply the I.V.T. for a given function, you have to check if the two conditions are satisfied for the given function. Now I will start the solution of this equation. Suppose that a function f is continuous everywhere and f of negative 2 equals to 3, and f of negative 1 equals to negative 1, f of 0 equals to negative 5, and f of 1 equals to 1, and f of 2 equals to 5. Does the I.V.T. guarantee that f has a root in the following intervals? We have 4 parts, 4 intervals. Simply, I want to say that the intermediate value theorem says that 0 is between positive and negative numbers. This is the idea, and I think all people knows that. Okay, it is not a new idea. 0 is between positive value and negative value. This is what I.V.T. says. Now in part A, you have to check if you have a root in the given interval, or we can say that 0 on the interval or solution on the interval. All these words are equivalent to each other, and we can say that the function cuts the x-axis at a point C. So also cut the x-axis means the same 3 words here. So in part A we have the interval from negative 2 to negative 1. So if you want to check if f has a 0 in this interval, first you have to check what is the sign of f of negative 2 and what's the sign of f of negative 1. And before that you have to check the conditions of the I.V.T. Now f is continuous everywhere from the question, which means it is continuous in the closed interval from negative 2 to negative 1. So f is continuous on the closed interval negative 2 and 1. So the first condition satisfies for the function f. And second, you have to check what is the sign of f of negative 2 and what is the sign of 1. So you have to plug in the endpoints of the interval in the given function. But everything is given for you in this question, because f of negative 2 is given and equals to 3, and 3 is positive number, it's greater than 0, and f of 1 is given also and equals to 1. So the second condition not satisfied because the signs of f of negative 2 and f of 1 are positive, and I.V.T. tells us that the signs must be different. F of A and F of B have opposite signs. So the second condition not satisfied for this interval, which means that I.V.T. doesn't guarantee the root. Now in part B with the same steps. Firstly, the function f is continuous everywhere from the question. Since it's continuous everywhere, it means it's continuous on any closed interval. So f is continuous on the closed interval from -1 to 0. Secondly, you have to check what's the sign of f of -1 and f of 0. Now f of -1 is given and equals to -1, which means that f of -1 is a negative number, and f of 0 is given equals to -4. So also f of 0 is negative. So we have the same signs for the image of the endpoints under the function f, which means I.V.T doesn't work in this interval. Now in part C we have the interval from -1 to 1 with the same procedure. F is continuous everywhere from the question, which means f is continuous on the closed interval from -1 to 1. So the first condition satisfies for the function f. Secondly, you have to check the sign of f of -1 and f of 1, the endpoints. Now f of -1 is given and equals to -1 again. So f of -1 is a negative number, and f of 1 is equals to 1, which means positive. So we have different signs here. We have opposite signs. So this guarantees the second condition also. So I.V.T work in this interval and guarantee there is a root. So there is a root and the open interval from -1 to 1, and the I.V.T works in this interval. Now in part D you have the interval from 0 to 2, and again firstly f is continuous on the closed interval from 0 to 2, since it is continuous everywhere from the question. And secondly, you have to check what is the sign of f of 0 and what is the sign of f of 2. Now f of 0 equals to -4, which is a negative number, and f of 2 is given also and equals to 5, and 5 is a positive number. So we have opposite signs for the substitution of the endpoints under the function f, which means the two conditions of I.V.T satisfies for the given function. So there is a root, and I.V.T guarantee the root of the function f. And that's it. Thank you very much.